Okay, next we want to look at the ruler postulate. Now, the ruler postulate sounds fancy, but a postulate is really just something that we're going to accept as a given. Okay, this is true. Sometimes we'll call it an axiom. But the ruler postulate mainly gives us the ability to measure distance between 2 points. But what it says is that, and it's got a picture here. If you have a point A and a point B, you can go from A to B and just assign, real numbers to the values between here. So, for example, let's look at this ruler down here. We've got ST, and let's suppose you start S at 2. Then you can say, okay, there's 3, there's 4, there's 5, and T is about 5.5. In other words, you can order the numbers on that segment that way. And that gives us the ability to talk about distance. So, for example, if I want to talk about, well, what is the length of this line, ST? How long is it? So I've got ST. I want to know how long that is. I'll just denote it this way. This, not the line, but the segment. Well, it's going to be the difference. 5.4, looks like, about 5.4, minus 2, and that would be 3.4. Yeah, 3.4 centimeters in this case. That's all we have. That's all you do to measure the distance. Now, look, sometimes though, it doesn't matter if we start with the big number and subtract the smaller. What we could do is this. We could say 2 minus 5.4, and then we get negative 3.4. Now, it doesn't make any sense to talk about negative distance. So what we do is, whenever we talk about measuring distance, we always put it in absolute value. Because remember, what absolute value does is it takes away the negative. So we could say 2 minus 5.4. In other words, we just simply do subtract the difference. Okay? Now, so we want to know how to measure the distance between 2 points, and that's just the absolute value. Now let's look at the next postulate, the segment addition postulate. Once again, very simple idea. Let's suppose we've got this segment here. It starts at A, ends at C, and B is a point in between. So we've got this segment AC, and we want to talk about the length of AC. Okay? If I want to talk about the length of AC, and notice I didn't put the little line above it, that way we know that we're talking about just the length here. Well, I could measure the length from A to B and add that to the length from B to C. So see, that's an example of the segment addition postulate. That's simple. Okay, so you just stop here at B and then you pick it up again at B. So you just add those. You add this distance and this distance. Very simple. Now let's look at an example here. So we want to find GH. We want to find this length right here, and it's not outright given to us. I mean, we know this whole length across here is 36. So here's what we know. We know 36 is equal to 21. See, we know it's this length plus this length here, plus GH. Okay, so this is the game, this is how we can use the segment addition postulate. So we've got 36 equals 21 plus GH. So this is just a simple algebra equation. So I can subtract the 21. And what do I get? I get 15 equals GH. Yeah, so that's it. Okay. Now, here's another thing that, now a lot of geometry is about definitions, and we just want to be sure we're speaking the same language. Especially in this first chapter, we lay a lot of groundwork. Now, we can talk about segments that are congruent. And we denote that this way. Little equals with a little squiggly above it, okay? So if two line segments have the same length, we talk about them being congruent. So notice here, I put this little box here. AB is the same length as, AB is the same length as CD. Therefore, they're equal this way. AB is equal to CD. But notice, I don't have the little line above it. There's no line up there. So that's talking about the measurement. In other words, this is saying AB's measurement is the same as CD's measurement. Okay? Now, if you put the line above it, you talk about the segments being congruent. So here's the deal. Let's suppose HP is equal to 5. And let's suppose QR, this segment, the measure is 5. Okay? So in other words, the length of HP is 5 and the length of QR is 5. Notice no line above them. But if I put the line above HP and over here QR, I'll put the line above it, then they're congruent. So over here, HP is equal to QR. But if we talk about the segments, in other words, that's the measurements. So make that distinction. If you put a line above it, then you talk about congruence. Yeah, congruence. Okay, now let's go down here and talk a little more about these. Here we've got some points. We've got the point -3, 4. It's right here. There's J. And we've got all these points plotted. K is 2, 4, so we go over 2 and up 4. There's K, over 2 and up 4. And we've got all these points plotted. Now what we want to do is we want to find the length of each of these segments. For example, I want to find the length of JK. Okay. Well, so let's see what that would be. That's going to be the absolute value. Notice the y's are the same, so all we care about is the x's here. See, we just want to know the length from here to here. Has nothing to do with the y's. Okay, so here's what we've got. We've got 2 minus a -3. Remember, put it in absolute value. And this is 2 plus 3, which is 5. Okay, good. Now let's look at LM. Let's see what the distance there is. So this time we're dealing with the y's. 3 minus a -2. And that equals the absolute value of 5, which is 5. Ooh, those are equal. JK does indeed equal LM. Therefore, JK as a segment is congruent to LM as a segment. There it goes. Yeah, that's it. So mainly this section you're learning to find the distance between 2 points. Now down here in the assignment, you'll notice I've got various problems that I think I addressed in this video.